editorial for CSES problem set dice combinations. Okay, so the problem is your task is to count the number of ways to construct some n by throwing a dice one or more times. Each throw produces an outcome between 1 and 6. For example, if n is 3, there are 4 ways. And for the input, the only input, well, n, and then the ways, the modulo 10 to the power of 9 plus 7. Right, so here. So this is obviously a DP problem, dynamic problem, programming problem. So here, let's see. So, well, we can obviously just loop through n and 6. So here, I'll explain. What we will do is set dp 0 0, meaning or well, let's make it ij for now, meaning that there's which is the number of ways, or actually we'll just do this, number of ways to produce I, right? Or yeah, number of ways to produce I, produce the sum of I using the values on a dice. And then to figure out DPI, we do plus equals DPI minus 1 plus DPI minus 2, and so on until DPI minus 6. Right? So that means number of ways to get I guess so number of ways to get I minus 6 plus 6, so we roll a 6, right? And then well, we'll just add these up, right? So the values on a dice. So I guess what I'm trying to say is we just roll roll the dice 1 2 3 4 5 6, and then just count how many ways we can get I minus 1, I minus 2, and so on. So yeah, so that's how we're gonna do it. I'll just comment this out. So int n sin n, and then I've stored mod to be this, which is just 10 to the power of 9 plus 7. So yeah, so mod is gonna be 10 to the power of 9 plus 7. And then I'll just do long dp. So LL, it's just short for long. I've specified it there. Long dp n plus 1. Memset dp 0 size of dp. Basically what that does is it sets every value in dp to 0. And but we want dp 0 to be 1 because there's one way to make dp 0, and we'll just add on from there. So this is basically like the base of our whole operation, right? So for int I equals 1 and I, oops. Now what we want to do is for int j equals 1 and j 6, j plus plus, and we want to say if I minus j. So which checks if I minus j is greater than or equal to 0. So well, I should probably just do this. Greater than 0 or equal to 0. Then we do dpi plus equals dp I minus j. Right? And then that's basically the code. Else we can just break. Or yeah. And then see out, oops, I forgot something. dp I mod equals mod. So we're just taking the modulo of it. And if you don't know about modular arithmetic, I suggest you check it out. So basically here, I'll try to explain it right here. So a plus, you want to memorize these by the way, a plus b m is a mod m plus b mod m, and then the whole thing mod m, right? And then it's basically the same format for a multiply as well, so I could just copy and paste this actually. It's also the same for minus, multiplication, and then there are none for division, so be careful about that. This rule, I guess, doesn't work for division, so it's only addition, subtraction, and multiplication. And then C up dp of n. We just output that. Hold on. Main.cpp. And then 3 is 4. That works. We'll just submit CPP. And we'll just submit it. That works. Here we'll do another problem. Another DP problem. Minimizing coins. Positive integer value. Your task is to produce a sum of money X using the available coins in such a way that the number of coins is minimal. So we want to produce a sum of X using the minimum amount of coins, right? Okay. All right. So, okay, here we go. So this is this problem is also very similar regarding, well, similar to the previous problem, so we can just do this actually, or yeah, we could just do this same thing till there, and we just get X. So how we want to do the problem is that we want to do it by so here we'll have a base case. I'll just do it here actually. So base case of dp, we also want to use a dp thing. So dp of I is a amount, so number of coins to produce I, right? And then to get dp of I, we do dp of I minus, I guess, coin 1 plus 1, and then we just want to choose the minimum of that, and then dp of I minus coin 2 plus 1, and then blah goes on for all the coins. So I forgot to explain the time complexity of the last problem, but so for the last problem, O of n is going to be last problem will just be O of n times 6, but we just do n, right? And this problem, it's the same of, actually no, it's not the same, of n times x, right? Because so nx, because for each value we want to loop over each coins and then get the value. So that's that. So we get int, yep, we just get we did all the inputs, not all of it, but I guess we'll just do int r of n for coins. And instead of n, we will do x. for int I equals, actually we wanna memset dp memset dp to mod. So we want, instead of making 0 this time, we want to do a great number, the greatest number possible, because so we're trying to get the minimum, right? Minimum of these values, and we just want to do the contradiction of that, so that we don't get the filler as the answer. Okay, so for int I equals 1, I plus plus, and then the base case is dp 0 is 0, obviously. For int j equals 0, j equals 1. Okay, so if dp of, if I minus r of j is greater than equal to 0, same thing as last time basically, and then dp of I equals minimum of dp of I, and then dp of I minus rj plus 1. So what we do here, and then we just print out dp of x. I hope this works. Oops. 3, and that is correct. We'll just go over here, submit the file, and whoa, we have a couple wrong answers. Here actually, it's not a good practice to look at these values, so all right, we'll just try to figure it out on our own. And that's like, whoa, hold on. Yeah, that's like this is just as like a lookout in case we're having like an integer overflow. So we're just making it long. I don't think we have any like time by making it long, we won't have like, it's still gonna work under the memory constraints and the time constraints, and so it's just safe to do that. And I'll just loop through it on my own. And because sometimes memset doesn't work accordingly. So mod and then I forgot a case. So okay, so if dp of x equals mod, we just print -1 else, yeah, dp. Okay, so I just forgot the base, or one of these cases. I think the ones that I got wrong are those. Yep, and it does work. So as you saw on both of those problems, the DP, I guess the dynamic programming, or like the overall structure was very similar. So we were just trying to solve for like one of the states using the previous state. So, and that's basically what DP means, right? Dynamic programming. We just used previous states that we have already visited to solve the current state. So that's exactly what we did. And yeah, bye bye. Yeah.